What is a chirp signal in gravitational wave detection? Imagine listening to a sound that starts low and slow, then gradually rises in pitch and loudness. Now picture that happening in space, but instead of sound, it's a ripple in the fabric of space and time. That's what a chirp signal in gravitational wave detection sounds like in the universe. When two massive objects like black holes or neutron stars orbit each other and get closer, they produce these unique signals. The waves grow stronger and faster as the objects spiral inward, creating a pattern that looks like a rising chirp. This process begins when the two objects orbit each other, emitting gravitational waves that carry away energy. As they lose energy, their orbit shrinks, making them move faster and closer. The gravitational waves they produce become more intense and higher in frequency. When they finally collide, the signal reaches a sharp peak, then quickly drops off as the merged object settles down. This entire pattern is called a chirp because it sounds like a bird's rising call, but in the case of space, it's a pattern of ripples in spacetime. Scientists study these signals because they carry a lot of information about the objects involved. One key piece of data is called the chirp mass, which is a combination of the two objects' masses that influences how quickly the frequency increases. By analyzing the chirp, researchers can figure out the masses, spins, and distance of the objects from Earth. Detecting these signals is a major part of gravitational wave astronomy. Instruments like the Laser Interferometer Gravitational Wave Observatory, or LIGO, use laser beams in long tunnels to measure tiny spacetime ripples. These detectors are incredibly sensitive, capable of sensing distortions smaller than a proton's width. When a chirp signal is detected, it confirms that a cosmic collision has occurred far away. The discovery of these signals has opened a new way to observe the universe. It confirms predictions made by Albert Einstein's theory of general relativity and allows scientists to study cosmic events that are invisible to regular telescopes. These signals tell us about the most energetic and distant phenomena in space, helping us understand the universe's history and its future. In short, a chirp signal in gravitational wave detection is a rising pattern of ripples caused by two massive objects spiraling into each other. It acts as a cosmic fingerprint, helping scientists identify and learn about some of the most powerful events happening in space.